Good afternoon again, everybody. Thank you for coming to PA Museum's Lunch and Learn today, protecting the building that protects the collection. We have with us today Justin Spivey from Klein and Hoffman in Philadelphia to present about some challenges for museums and history organizations around their buildings and what can happen surrounding their buildings. We're very grateful for Justin's agreeing to join us and share his knowledge with us. We will try to have some time for question and answer at the end. I will monitor the chat for questions as we go, and we're going to try to save them until there at the end of the presentation. Thank you again, Justin, and you can start whenever you're ready.
All right. Well, thank you all for sharing your lunch hour with me. Although I understand that some of us are joining from different time zones, so welcome from whatever time you are. And I'm going to turn my video off just to preserve bandwidth and remove distraction while I'm speaking, but I'll come back on camera for Q&A at the end. So some of the alphabet soup after my name comes from the Association for Preservation Technology International, which is dedicated to caring for and protecting the built environment. The APTRP credential recognizes specialized knowledge, training, and experience in the use of preservation technology. I'm also the vice chair of the Delaware Valley chapter, which, despite its name, also serves the Susquehanna and Ohio valleys. You can visit our respective websites for more resources and educational opportunities. Here are the learning objectives as stated in the announcement, and I'll give you a moment to read them again. To thank Pete Siebert of the Independent Seaport Museum for introducing me to your organization. I want to thank Rusty and Patty for helping set the vision for this presentation, and the clients who've brought me interesting projects over the past 30 years, some of which appear as images in this presentation. Where the work is associated with a previous firm, I've credited them in the margins. As I don't have a photo for every concept I want to cover today, I will enlist the help of two characters from historical fiction. On the left is a historic house museum called the Guy von Holland Homestead, built in 17 whatever, with a steep roof that is wood framed along with the walls and floors over a cellar. On the right is the Phil M. Boxes Archive Center, named for its benefactor in the mid-20th century. It has a low slope roof, steel framing clad in masonry, and a concrete slab on ground. As you can tell from these two characters, I believe in the power of storytelling to help explain technical concepts. And the construction industry tells many that are too good to be true. These include the myth of zero maintenance and its cousin maintenance free. But as the guardians of documents, physical artifacts, and interpretive exhibits, museum professionals might be painfully aware that all materials deteriorate, especially in buildings that we're always leaving out in the rain. Perhaps you have always also noticed that even so-called stainless steel forms rust with exposure to chlorine, de-icing salt, or ocean air. Durability is often determined by these details, and those details are the choices of owners, designers, manufacturers, and installers. As an example of this, the engraving of number 435 on this plaque seems shallow and more susceptible to weathering than the raised letters around it. But given the slow rate at which bronze corrodes, I doubt it will become illegible before these ferrous fasteners fail. I don't know whether the screws were supplied with the plaque or selected by the installer, or whether anyone explicitly considered the trade-offs between strength and corrosion resistance in these different metals. I do know that the screws will be a higher priority for maintenance than the engraving. Here in Pennsylvania, we have a strong tradition of the master builder, who both provides the design and constructs it. And this worked well in our early history when buildings were smaller and simpler, were constructed of more robust and durable materials and did not have as many different materials and systems to integrate. As new buildings have become more complex and have aged into the existing buildings with repair and maintenance needs, increased specialization is needed with separately licensed design professionals to help building owners identify problems and develop solutions for contractors to implement. Despite this, some contractors continue to offer one-stop shopping to owners with little or no design professional involvement. This attitude is encouraged by a building code that does not require permits for certain types of repair and maintenance work, allowing it to proceed with minimal design oversight or code enforcement. To illustrate the different motivations of contractors and designers, let's say you've noticed leaks inside your museum building. A roofing contractor who is motivated to sell solutions that involve roofing materials and labor might point out that the shingles are weathered and curling and recommend removing and replacing all roofing. That would only solve the problem if the leaking components are within the roofing. A design professional who's motivated to sell solutions that involve investigation and design services might point out that leaks more often originate at penetrations and edges and recommend an investigation. This could identify problems beyond and above the roofing, such as water entering through deteriorated masonry in the chimney or bypassing flashing in the rising wall. Although the weathered and curling shingles are still a concern, the designer can help the owner prioritize localized repair now and budget for roofing replacement later. I'm not saying that contractors don't have owners' best interests at heart. I'm saying that contractors tend to focus on how to perform the construction work, and owners also need designers to focus on why. If an owner starts from the perspective that construction work needs to be done without a complete understanding of the problem to be solved, the contractor could end up installing the wrong material or the right material to the wrong extent, addressing symptoms of deterioration for the short term while concealing root causes that continue to progress out of sight. Contractors who are used to working without design professional input are also the ones who most often speak the 6 most dangerous words in the English language. We've always done it this way. Design professionals can help counter this tendency by identifying the root causes of distress and considering the owner's priorities and budget in developing a scope of repair work. Designers who specialize in evaluating existing buildings can leverage that experience to specify materials and details based on known performance. For example, selecting a joint sealant that doesn't migrate into and stain granite. The designer should remain involved during the construction to review the work for conformance to the design and respond to unanticipated conditions. Designers can also provide quality assurance services such as testing system performance and collecting warranties and maintenance instructions for the owner. I will come back to this in the last section when we discuss collaboration between owners, designers, and contractors. The design professional is also responsible for interpreting information for the contractor through the construction documents. First and foremost, the owner's requirements and the building code. In addition to the standards that are explicitly referenced in the building code, there are others written to meet the needs of different needs of historic properties, such as this ASTM standard for masonry repair mortar. It's an alternative to the code reference standard for mortar in new construction. You could read more about it in this practice point available free at apti.org. The Secretary of the Interior standards might also apply as a condition for funding, or they might just provide a guiding light for the project. And beyond this, there are many other non-mandatory guidelines for preservation treatments that a design professional could translate into mandatory requirements in a contract for construction. Identify situations where a museum might need to engage a design professional. I'm going to cover 3 categories of threats to museum buildings, and by extension, to the collections they contain. Let's start with the exterior environment. With increasing frequency and severity of weather events, there's an increasing risk of wind-borne debris damaging buildings. One source of material Lurking in plain sight is trees, whose branches not only can break off, but also can scrape against roofs and other building surfaces. Trimming branches away from buildings and removing leaves from roof drains are ongoing maintenance tasks. But a landscape architect could also be engaged to select new species with different growth potential and locate them at an appropriate distance to reduce those maintenance needs. Another easily overlooked source of debris impact is signs and similar objects that are light enough to be picked up by strong winds. Permanent signs should be adequately anchored, and temporary signs should be weighted down. That seems like too much work for a sign that is deployed every day. Think about the damage it could cause if airborne, and then think about a different solution for communicating with visitors. Wind can also blow off building enclosure components such as roofing and siding, particularly if the fasteners have deteriorated or weren't even adequate to begin with. Windows in unoccupied attics generally get less attention, which applies to preventive maintenance and to being noticed when they're damaged by wind. The resulting new paths for water infiltration might not be noticed until the leak works its way through the attic and into occupied space. For this reason, it's prudent to walk around the building and check all roof surfaces on a regular basis and after each severe weather event. For roofs, the minimum recommended frequency of inspection is twice a year. In the spring before summer thunderstorms arrive, and in late fall after most leaves have fallen. Items to check for include deteriorated or displaced flashing at roof penetrations and perimeters, clogged drains at low slope roofs, clogged, displaced, or disconnected gutters and downspouts, and site grading, which can also be an issue if the ground slopes toward, or if the ground surface slopes downward toward the building. Older buildings typically lack basement waterproofing and foundation drainage, and installing these would require deep excavations around the perimeter. It might be less disruptive to adjust the ground surface instead, so it slopes away from the building, either with a landscape swale for our historic house on the left, or perhaps a hard surface terrace with a drain for our archives building. Engaging a civil engineer and possibly also a landscape architect to design these is recommended. Water can enter cracks and open joints in masonry, freeze, and expand, widening existing cracks and creating new ones in a progressive cycle of deterioration. Water can also corrode embedded steel lintels and anchors, with the resulting iron oxide taking up several times the volume of the original steel. In both cases, the expansive force can displace masonry and create a hazard of material falling from the building. Although cities such as Philadelphia and Pittsburgh require formal inspections of taller building facades at 5-year intervals to reduce this risk, walkarounds on a regular basis and after severe weather events might be a good idea for buildings of any height, especially public-facing ones. So these blueberries from the farmer's market could have made delightfully purple milk in a cereal bowl, but they were left behind and they made less delightfully purple granite. Whether this is an innocent mistake or there is a less innocent act of vandalism, our first response should not be to call a contractor with a power washer. Design professionals who are knowledgeable in the cleaning of historic masonry will understand the staining and the substrate, propose different options to try, and review the results to identify the gentlest possible method. This often involves controlling the water pressure and literal elbow grease with a detergent and brush to avoid damaging masonry and removing mortar. I will forgive you for reciting the old horror movie line about the call coming from within the house here. We love our visitors, but there can be too many. especially in historic house museums with wood frame floors that predate the practice of structural engineering. Humans standing in a crowd can easily double what a residential floor is capable of safely supporting and crack plaster ceilings below. In administrative and archival spaces, paper can even be heavier. One of my favorite examples of occupants unaware of the risks they were creating was this state Senate print shop, not Pennsylvania's, where thousands of pounds of paper were on a floor suspended by wrought iron bars from roof trusses directly over the senators. One way to manage this, although less than 100% reliable, is to post instructions alerting occupants to the limitations of the structure. Another approach is for a structural engineer to evaluate the floor load capacity systematically throughout the building and use the resulting load map as a planning tool to select the most appropriate rooms for heavy exhibits, public assembly, and other uses. Electricians and plumbers are often blissfully unaware of their impacts on building enclosure performance or on structural capacity. These impacts also tend to accumulate over time, with gradual enlargement of holes for maintenance access growing large enough to cause structural distress. Design professionals can help by reviewing the layout of proposed new building systems in drawing form so that mistakes are caught on paper before they become cuts into historic building fabric that is difficult to repair or replace. And then there are those pesky occupants, always breathing their warm, humid air next to fragile artifacts, doing unpredictable things with plumbing, slamming doors open so their handles punch into historic wallpaper, and so forth. My recommendation here is to notice when something happens more than once and ask whether changing the design would prevent it from happening again. If it's a building system that is repeatedly overloaded, it might be time to call in a mechanical, electrical, or plumbing engineer. Our third and final category of threat comes from below the building, or more specifically, from the ground that supports it. My former colleagues at WJE have written and presented extensively on their experience gained from construction next to large museums, including this article in APT Bulletin. We should all be so lucky that the Art Institute of Chicago or the St. Louis Museum of Art have the resources to expand and the space to move fragile artifacts away from interfaces with new construction, which is a strategy for these large facilities. But this knowledge is also relevant to smaller buildings. To manage the risks of adjacent construction when expanding this archive building, or perhaps reconstructing a long-lost wing of the Historic House Museum to provide accessible restrooms, it might be necessary to relocate some or all of the historic collections off-site during the construction period. We can also manage risks to buildings and collections through monitoring. Here are two crack gauges on the bottom, more remotely read through a website, and on the top, a dumb but reliable telltale as a backup. On the right is the seismograph mounted near the foundation for measuring ground vibration. For these systems to be effective, there must be an alert threshold set well below the level that is expected to cause damage. Essentially a yellow light telling the contractor to slow down and modify their operations. The second limit is the allowable limit, a red light that stops work, ideally before the damage occurs. Ground vibration is challenging to monitor because humans are effective as seismographs, just not as well calibrated. We can perceive vibration at very low levels, about a third of what is caused by passing traffic. The generally accepted limit to avoid cracking historic plaster is 5 times more intense, and the level of vibration expected to cause structural damage is higher still, probably well beyond the point at which staff complaints have motivated the museum director to call the contractor. Along with my former colleagues at WJE, I've written and presented about how risks become even more challenging to manage when the construction is not a building addition for the same museum, but rather someone else's project across the property line. The webinar on the right was an hour and a half and barely scratched the surface of these complex risks. But one takeaway is that excavation doesn't have to directly adjoin a building to present a risk to it. The zone of influence represents how foundation bearing pressure spreads outward below the ground surface, idealized as 45-degree lines from the bottom corners of the wall or the footing. Excavation and new foundations that cross these lines will affect the distribution of bearing pressure in the soil, creating a risk of ground and building movement. There are numerous excavation support strategies to mitigate this risk, one of which is underpinning, or systematically removing small volumes of soil in sections along the length of the wall and replacing it with concrete piers to a lower bearing elevation. This technique has a long history around the world and is still commonly used in Pennsylvania, particularly in Philadelphia. Another issue with a long history, but not related to adjacent construction, is rising damp. The Romans noticed that moisture would be drawn upward from the ground into masonry walls and therefore inserted a course of less permeable slate to prevent it. 20th century masonry references similarly recommend a layer of asphalt and acknowledge the use of slate for this purpose. Somehow, between these two dates, this became less well known and many foundation walls were constructed without it. Moisture rising from the ground can be a problem with our historic house museum, with exposed soil or perhaps a brick floor in the cellar, or in our archive building, which may have been built with inadequate or missing vapor barrier under the concrete floor slab. The problem can be made worse by dehumidification that is often expected in museum environments, with drier air pulling even more moisture from the ground. This is the second time during this presentation I'll recommend calling an MEP engineer. So now that I've listed the threats to historic building and museum buildings, here are some responses. Maintenance and repair priorities should always be based on a comprehensive understanding of the building's current condition. But if your museum already has shelves laden with condition assessment reports, please don't ask your consultant to write another one from scratch. It would be more productive to read through what's been written already and understand which recommendations have risen in priority, which were previously implemented, and which have been overcome by events. If funders insist on a report, consider negotiating a briefer one that summarizes previous work and updates the list of repair and maintenance priorities. In our digital age, there's no reason not to keep these priorities in a running and active list and to set calendar reminders to review that list on a regular basis. So once we have our conditions, we can place them in order of priority because there is just never enough resources to address them all. But some will always be high on the list, notably managing the risk of material falling from the exterior of the building. As I mentioned, some cities require periodic maintenance inspections for this purpose. Preventing leaks from causing structural damage and repairing that damage when it's already occurred are typically next in the order of priority, with fire and life safety systems also near the top of the list. We should not neglect the regular maintenance that prevents problems from developing. And given that museums would not exist without visitors, many of us would argue that accommodating those visitors and helping them enjoy their time are equally, if not more important. And this is a lot to keep in mind. But as a further argument for periodic maintenance, consider the inevitability that a building's condition will decline over time. Working through our list of priorities on a regular basis can prevent conditions from falling too far, keep the cost of repairing them low. And spending a little one year resets that condition, spending a little the next year, and so on. This keeps that in slow decline. But if conditions are allowed to decline long enough, the rate of deterioration will accelerate, and the cost of the repair will be higher in the aggregate. I know you know this, but do your funders? Another opportunity for economy is in combining projects. Consider a hypothetical list of priorities, including replacing a failing rooftop mechanical unit, a facade that needs some maintenance, and a roof that was recommended for replacement in 5 years. If these were completed as three separate projects, we would be paying for three contractor mobilizations and three means of access for these three projects, not to mention patching a roof in year one that gets replaced in year 5. But if we could find a way to finance a larger project, use the same crane to lift both the rooftop units and the roofing material, repair the most heavily weathered masonry at the top of the building while we're there, perhaps the rest of the masonry can wait, and we would only be paying for mobilization and access twice. The running list of priorities can also be rearranged as needs and available resources shift, as they inevitably do. If low slope roofing was low on the list, but grant funding becomes available for that purpose only, it can and should move up the list. But we should be careful because moving ahead of the chimney and bulkhead repairs, the mason will now be working above a brand new roof. This would increase the need for and cost of roof protection. In working the list of maintenance and repair priorities, we should look for opportunities for collaboration between museum staff, designers, reviewing agencies, and contractors. This will go without saying for some, but my recommendation is for every museum to treat its buildings as it would any artifact in the collection. Curatorial research and facilities staff can collaborate to compile the original drawings, the history of alterations, repairs, and maintenance. And this might be written into a historic structure report that's prepared by the staff or consultant and kept updated as maintenance and repairs continue to be undertaken. We can also take this a step further by identifying the materials present in the building, researching the manufacturer's product data. APT's Building Technology Heritage Library can help with this for archaic materials. Even uncovering what the original manufacturers thought of the capabilities of their products and maintenance instructions they might have provided with them. For more recent materials, I'm often surprised by how difficult it is for some owners to confirm whether they have warranty coverage, for example, on a roof where the manufacturer's representative could come out and assist with the selection and design of roofing repairs in order to maintain that warranty. I advocate for an all-hands approach to protecting the building that protects the collection. Of course, we should include museum leadership who make decisions, the facilities maintenance staff who have to implement them, the finance staff who have to figure out how to pay for them, development staff who raise the funds, and the collection staff who not only hold the information about the building that can help the consultants do their job better, but are also sensitive to thermal and moisture issues that might be occurring out of sight. I recognize that many of these roles are combined in smaller museum staffs, but the point is that all staff use the building in some unique way and might notice things that others don't, and might need to be prompted by a building condition assessment to share their knowledge And so on some of these comprehensive condition assessments that I've performed, there's an interview phase where we sit down with a selection of or the entire building staff, or perhaps a survey is sent out to collect issues that they've noticed before we begin our assessment so that we can choose where to target it. I will also advocate for collaboration between owners, designers, and reviewing agencies, whether that's the local building department, State Historic Preservation Office, National Park Service tax credit reviewers, or so forth. To the extent we can, letting them know about a forthcoming project, then soliciting their input, emphasizing that the museum cares about its historic building. Reviewers might be more receptive to discussing what might be possible with limited available funding. And where there are multiple treatment options available, helping find mutually agreeable solutions that meet historic preservation requirements, owner's budget, constructability concerns, and so forth. Although I advocate against engaging a contractor without design professional input, I also advocate for collaboration between contractors and design professionals. During the condition assessment phase of a project, contractors can help us get into difficult to reach parts of the museum building and remove finishes called exploratory openings to reveal concealed conditions. Contractors can contribute during the design phase of a project by testing repair methods for proof of concept. And I found this very successful in helping a contractor understand the labor steps that are involved in performing a repair that might be novel to them, understanding the time and tool commitments to that trial repair and documenting that in the construction documents could lead toward tighter bids during a full-scale construction phase. Contractors can also help identify more constructible solutions and less expensive ones. The trade-off here is that a contractor who's involved in a design assistance role may be hesitant to do so because it would mean not being able to compete in bidding for the final project. And likewise, an owner might not be comfortable with sole source procurement for a contractor who's already been working on the building. My counter arguments here are that a design assists contractors increased knowledge of the building could lower their price, and that price could be checked by an independent cost estimate. And so I will leave you with these thoughts that traditional design, bid, build, procurement tends to place the design team and the construction team in opposition to each other. They're both working for the owner and sometimes at contrary interests. So traditional design, bid, build is not the only option for repair and maintenance projects. There are definitely more collaborative project delivery alternatives out there. These are worth exploring, and these are worth convincing funders of their potential for better results. So I am grateful for your attention and look forward to discussing your maintenance and repair challenges. And although I thought time would be tight here, I think I was going pretty quickly at the beginning of the presentation, and so it looks like we have quite a bit of time for questions.
Well, thank you, Justin. I was checking the chat and I haven't picked up any questions there. If anyone would like to ask a question, please feel free to use the raise hand function or unmute and question away.
Yeah, if I might ask a question of the audience, it's whether anyone has had experience with alternatives to design, bid, build project delivery, whether you've had experiences with construction managers or owners reps um, intervening between the museum and the design team.
Hey, Justin, this is John Wood. I work for the SHPO, and one of my experiences has been pretty successful in dealing with the historic buildings is because some of that work is so specialized, it's always good to have like craftspeople who deal with it instead of, um, you can do it two ways, one of which would be have them work as subs to a general contractor, but oftentimes it's more productive to hire them on an individual basis for that specific work. And I don't know if you've seen that work either way and what you recommend as far as implementing specific craftspeople into a larger scale project.
Um, yeah, I'll say that I don't have a lot of experience with like direct engagement with craftspeople on anything larger than like small residential scale. But I'd say there's a question of both the scale of the project and the level of trust that might mitigate here. That if it's a small restoration where we're just improving the condition of some existing piece of the building, there's not a lot of question of design issues or public safety concerns. And also, there's a great deal of trust between the museum and a small business. That might be somewhere where the design professional would have minimal involvement and not have the formal construction documents and AIA contracts and so forth that we have with a larger construction project. But that said, I want to underscore the point about maintaining the treatment record. And in a museum building, particularly one where the building is the artifact, having that room by room record of what was done and who did it just really enhances the designer's ability to understand the evolution of the conditions as they currently stand and to play that information into the next repair or maintenance campaign. But thanks for sharing that, John.
It looks like we have a few questions coming through on the chat. Justin, one from Peter. What's your advice for someone coming to a new historic site or house museum as the director? What should they be looking out for? What would you tell them?
Well, two things that come immediately to mind are um, first, getting familiar with it through your own eyes, with that walk around, get into every space, find the staff who've been there longest, and um, walk with them to learn what they know and to hear about their experiences with the facility. The other is to dive into that maintenance record, and it's some of my most favorite clients to work with are the ones who have a shareable archive, perhaps on some file sharing platform like OneDrive or Google Drive, where um, those records are shared with trusted consultants and someone can review all that information. And I think um, before sharing it, obviously that director would want to know what's in there and then be able to speak to it and answer questions about it. So getting familiar with the museum itself and also its documented maintenance and repair history, I think are very important.
Thank you. We have a another one here. Would a design professional provide feedback on selecting proper HVAC systems for a 100 plus year old building used for archival materials? I'm the archivist and archives manager at Vanderbilt University Archives, and part of my job is monitoring the environment of said building.
Yeah. I think you will find that there are a lot of HVAC contractors who are um, willing to go out on a limb and select and design a system. Uh, I would really recommend involving a design professional there, an MEP engineer, someone who could um, understand the system performance requirements, which are really quite specialized for archival facilities, um, and design the system for the contractor to install. And I think that that puts the risk of getting it right on where it should be on the system on the professional engineer as designer, and then the contractor can focus on getting the installation right. Um, but I would also advocate for collaboration between those two and having system installer input during the design phase can help with some of these tricky questions, such as, how do we get that unit into that room? Um, does there have to be a temporary wall opening? Could the unit be disassembled into smaller pieces and reassembled within the mechanical room? How do we route the necessary piping and ductwork through the facility? Um, it could even be a design build partnership between the engineer and the installer in order to get that system right and meeting the specialized needs of an archival facility, especially in an older building.
The next question is about construction companies. Do you have experience dealing with construction folks who throw change orders out, often waiting until they send the invoice to do so, and the work has been completed already? I've learned to um, confer with construction people heavily before engaging their services, but this was a hard lesson to learn. Do you have anything related to that?
Yeah. Well, a couple of thoughts there. First is having that owner representative role, and whether that's a formal independent consultant who advises on the project, or whether it's just someone on the museum staff who acts as the clerk of the works to keep the project running. Having someone in that role that's between the facility user and the designer and the contractor, ideally scheduling regular checkpoints, doesn't have to be a formal meeting, but just might be a weekly email update of what's going on with the project. Uh, because we should not be seeing change orders after the work is already performed. Yes, technically that work has been performed by the contractor at risk. They don't have the owner's agreement to pay for it. They don't have the designer's input on what that work needs to be. And so um, having those regular touch points where we encourage communication from the designer, who ideally should visit the site periodically during construction, and the contractor, who's there every day, um, hearing from them in advance of issues coming up, when unforeseen conditions are uncovered, when the physical reality of the building deviates from what's shown in the drawings. I mean, these things are normal occurrences in construction, and um, I think there is a tendency for people to keep the information to themselves or to struggle in silence and not share it. But if prompted to do so by a regular point of communication during the project, I think you can cut a lot of that off. Um, Also, I think it's change orders are um, encouraged by the design bid build project delivery model, where um, the admittedly incomplete construction documents are put out there. They're based on the building as it stands and is occupied, and then if it's an invasive repair where, say, a facade or a roof needs to be opened up and inevitably is going to uncover conditions, hopefully the designer has accounted for that possibility by including contingencies, allowances, unit price controls, and so forth. Um, But inevitably, we don't have X-ray vision and we don't have the ability to predict the future. So getting into a project through a hard bid, even with appropriate allowances and unit prices, has the potential for surprises, and that's where the change orders come from. And some of the more collaborative approaches, some of the risk sharing approaches of different project delivery methods might see those change orders come down.
Thank you. We have a question here. What's your experience with architects and engineers providing services gratis for historic properties?
Mm. Well, I'd say, we do need to earn a living, and it's we charge our clients for our time to provide those services. But that said, there are opportunities such as services in kind that could be considered a donation, and therefore a tax reduction for the firm is a possibility. Um, Also including the soft costs of design services in grants. I've also had some partnerships here in Philadelphia with the University of Pennsylvania through their Penn Praxis, which uses the learning opportunity for students to engage them in project work, and have managed to cobble together between grants, pro bono, student assistance, and so forth, a lower fee than I would have if bidding to the private sector.
Thanks. Yeah, the next one is the a question about HVAC again. I've been discussing with some other collection managers about the possibility of not needing an HVAC system in an historic house, especially one that has never had AC or central air, due to possible adverse effects a stable environment might have on the structure and its contents, that are used to riding the waves of temperature and humidity changes. Do you have any insight into that debate?
Oh, yes. And it is an ongoing one, particularly the aspect of um, insulating masonry walls on the interior if it's a historic building. And that is still an open question. And there's been a lot written about it in the APT bulletin and discussed at APT conferences, because um, building science is an evolving field. This understanding of the hygrothermal behavior of the building envelope and how um, inside conditions and exterior weather respond to each other through different levels of insulation, where the point of condensation is in the building envelope, and is that in a moisture sensitive material. So um, it's something that a lot of firms offer now. The building science, I would just be um, uh, careful in going down that road, because it's um, easy to construct a simple model. It is more difficult and requires much more experience to create a whole building model that works in 3 dimensions and considers all the different assemblies that we have and the different behaviors of windows and doors relative to solid walls, et cetera. So I do agree that it's a complex problem, that it's difficult to predict how a structure is going to behave differently once a HVA system is introduced. Uh, so um, I think the caution is definitely warranted in asking the question, do we really need this? But also in looking at the collection, um, can that withstand all the temperature and humidity cycles that the building is currently inflicting on it? Is that reducing the life of those objects that are in there. And maybe there are intermediate solutions such as improving ventilation without heat or air conditioning, or improving humidity control with that are not all the way to a fully heated and air conditioned building, but just some incremental approach. And a lot of the MEP engineers that I work with experience in historic buildings, do not advocate for those all-in solutions. They do advocate for incremental ones and improvements over what's there that might get you a little better performance in terms of artifact life. And especially for museum buildings, which tend to have this long hold period by the owner. This is not an apartment building that's flipping owners every 10 years. This is something that is with the same owner, presumably forever, and has a dedicated staff who could be trained to do things like traditional practices, like opening windows for cross ventilation and closing them before a storm, and having a dedicated staff who's capable of going through those rituals when needed. They could be effectively the HVAC system. And I think that's an intriguing possibility to consider for particularly in a museum environment.
Well, we probably have time for this one last question. Stephanie Carter says, you said something that impacted me. The building is an artifact. I'm in a government entity. Tips on getting maintenance and building managers to get on the same page of understanding the buildings matter too? Question mark.
Yeah, it's certainly an easy case to make for my historic house museum clients that that house is, the reason that visitors come to it to see what it was like to be in a building of that era. Less so for more modern facilities. And you think of our 1950s archive building that I cartooned during this presentation. But still, I think understanding that what's there has value, that if it weren't there, it would have a replacement cost to accommodate the same functions. And oftentimes that replacement cost is many times what maintenance would be. So we can also make environmental arguments about this and sustainability arguments. The greenest building is the one already built, et cetera. But I got this phrase from Adrian Scott Fine of the LA Conservancy. He uses the hashtag keep what we have on social media. And that really resonates with me, that someone built it. We've maintained it for a certain number of years, and it could go on indefinitely with appropriate repair and maintenance. So why not do that? Because what is the alternative? Tear it down, throw it away, spend the money for a new building. If it's agreed that we need to continue housing that function at that location, you need a building to do it in.
Well, thank you, Justin. We're bumping up right against the end of our time here. If I missed a question, Justin's last slide here has his email address. He has promised he will respond to questions after the program is over, and we're getting close to 1 o'clock now. I did want to also include that Karen Arnold from the Pennsylvania State Historic Preservation Office shared in the chat the Keystone Grant Program that the Commonwealth of Pennsylvania offers to help with planning and construction. There is a link there to that grants program. And if for some reason you can't find it, you can also feel free to email me after this. I am familiar with that link and can send it out to anybody as well. Thank you, Karen, for providing the resource. Justin, can't thank you enough for this. I think we could probably fill another hour just talking about deferred maintenance, uh, which is uh, which is something I think we deal with a lot of in Pennsylvania due to the age of our buildings. Maybe some other program, some other time. Um, but we appreciate your preparing for and presenting for us today. PM Museums will be having more lunch and learns every other month. So please keep an eye out on our social media and communications for upcoming topics and dates and times. Thank you all again for attending, and I hope we see you next time.
Thank you all.